we're looking at soil pits, and we've got 3 distinctly different soil types that we're looking at during the day, and so really when we're, and I'll get you to sort of help me a bit with this, so we're sort of starting to have a look at a soil pit here. First thing you normally look at it, what sort of layers can you see there, I suppose? So some comments on layers?
I think around 30.
Yep, so one around here, yep.
Around 35.
You've been reading the book. Any others? Yeah, well, I ended up with 6, but anyway, you haven't eaten your lunch yet.
Shallower north to 10.
Yeah, so we certainly put one in here, one around about down there, and I suppose down here somewhere. And I suppose that when you start looking at, the next thing we sort of look at is certainly having a look at textures. So you're starting off with a, I suppose, quite a sandy topsoil, so a nice sort of a sandy loam, I suppose. And I should say that the one in the book's actually taken from about 10 rows that way, but it's pretty similar to this. It's not quite the same, but it's quite similar. So you might see a little bit of variation in there. And as we go down through the profile, you can see we're already getting into sort of a sandy clay in that one. And so quite a pick up in texture as we're going down through, and just the limier layer, which I think was that 55 to 80 layer, is this one here. So still getting quite quite reasonable. You can feel a bit of grit in that one, as well as you hand that one around, and right down the bottom, I suppose, again picking up quite a clay layer down through there, and I suppose sandy loam increasing to sort of light clays and going right down through, and I suppose the interest that certainly in all the Riverland soils is to look at the sort of lime in the soils as well, and with this one here, I'll do it that there somewhere. So there's not much, a little bit of a slight reaction just in the top, or nil there. As we get into this layer, so starting to pick up a bit more of a moderate reaction there. As we head down through here, quite a bit reacting through here, and I suppose the so you're getting into sort of a very high reaction in that sort of 55 to 80 layer, and then probably starting to taper off a bit once we get down further. So yeah, so disappearing a bit once we get down a bit deeper into that profile. And I suppose in terms of the, I suppose certainly Riverland soil, sort of understanding some of that limestone layer, the lime in those profiles is quite important for some of the crop suitability type of stuff as well that's used around. And those of you that are from orchards and vineyards, you've probably got quite detailed soil surveys of some of your country that you've had planted, and sort of understanding, I suppose, a lot of them were done using various techniques, or through the, I suppose, the ISMS or through the Weatherby type techniques, and certainly there is a focus on understanding those carbonate classes, and I'll talk a bit more about them as we go. In the book, I suppose, we've just got actually this one here, I suppose, which I said it has taken up about 8 or 10 rows that way, where there's a lot more compost on it, but we actually took it from the soil, not on the area that's actually got the compost in it. So some of the other things to look at for soil types, I suppose, is your colours. So certainly the darker colours will indicate a bit more organic matter in the soil. You can actually see the stuff even that came in here when they put the pipe in. And I suppose normally with our colours of the clays, the redder ones this one's not as bright red, but it's a little bit dull, but the redder the better, I suppose, in terms of drainage and things like that. If you're getting sort of brown or yellow or mottled colours, normally indicating a bit poorer drainage. As you go down, the lime will influence the colour because it makes it a bit lighter in the subsoils where you're getting lime showing up as well in those profiles. So I suppose your colours will tell you some stories in that as well. The other thing of interest here is actually you have got a little water table down the bottom, which is sort of, we think it's probably more induced because either from the grower was talking about, he irrigates his lawn a lot, and also there's some wastewater that comes out of this shed over here when they. So, but we can actually test that and just see how salty it is, and the actual. Certainly, I mean, I think about 40 metres that way they start having drainage systems in this area. So you know there is a drainage problem around, and often linked to sort of underlying clays and things. Yeah, so that's about 4 decisiemens, yeah. Yeah, so it's certainly a bit saltier than what the irrigation water, as you know, given the water's probably 0.4 or something.
Yeah.
Yeah, so it has built up a bit of salt down that profile at that layer. And certainly in my experience, if you start getting that a bit higher up, even at that level, you start having problems with your vines.
So where did that carbonate come from?
So this certainly the carbonate here is all wind-blown carbonate. So I suppose the profiles, yeah, most of these profiles are blown in over time, move down through the profile. And you'll find, you know, within I suppose a clay matrix, this one here, there's a range of classes, I suppose, that the sort of when describing soils, and this one I suppose is in that clay matrix, so it's actually a class 1 carbonate sort of class. We sometimes find it can be linked to some of the other issues like high boron and high salt. This one we tested down to 1 metre, but we didn't see it here, but we have certainly seen it at one of the other sites. And I suppose that the interesting thing is, you know, is that water perched on top of an even denser clay down there, I suppose. And you know, you may be hitting an underlying, you know, blanchetown clay or something down there, which pretty well all the stuff above blanchetown clay is wind-blown material that's been reworked, moved in. Once you get to blanchetown clay, you're more in possibly an old lake or something like that where the blanchetown clay is formed, so very fine material. And then once you go underneath that, you start getting into the sort of more the marine type stuff that you hear about in the mallee, in the cliffs and things. Yeah. But so in your notes, I suppose there is a page. We did some lab analysis down through the profile, and I suppose we did look at pHs down through here, and that's really the. So they all look pretty purple, so they're all alkaline. So in terms of your pH. Those of you that haven't used these little kits, you know, pH is, the green is actually neutral. As you go to 8, you're becoming 10 times more alkaline. As you go to 9, you're becoming 100 times more alkaline, is the way to think of it. It's a log scale. And sort of running through those ones, so you can actually see from the top here, you know, on this field kit, you're up pretty alkaline to start with. Pretty well all the way down, you're sort of 8.5, sort of heading towards 9. And I suppose, normally with the pHs, you know, there's a lot of alkaline soils in South Australia. It's not really an issue in the sense until it gets over about 9.2 pH, I suppose, is our rough rule. We start getting pHs above that, you know, often we find the roots don't particularly like it. And I suppose that's, you know, another thing to look at in this one is this soil is just understanding where are those roots actually going. So when you look at, you know, a lot of roots up the top here, pretty happy. You've got these sort of funny roots heading along horizontally on there. Can you see those ones? So they're possibly hitting that sort of interface, I suppose, between where that clay starts to pick up quite a bit. You are finding that there's a reasonable number through here. Once we sort of start getting down a bit, you know, a lot less. The other interesting thing is, you know, with these sort of pits, you can also have a look inside and just see how many are getting past. Because, you know, sometimes you'll find there's very few roots get past the wheel mark because it's compacted there. But you are seeing quite a few, even in the rainfall we've got here, you know, they are moving in a bit too. So they're exploring, I suppose, outside of the dripper area here, I would have thought. I'm not quite sure when you wet them up here how far that dripper goes. But yeah, so normally you're wetting up to about there.
Yeah.
But we are seeing, you know, considerable root growth. They particularly like where he put his pipe in, of course.
Yeah.
As you see. So looking at some of that analysis, yeah, certainly pH is all alkaline. We did do nitrates, a different test to yours, and nothing showing up at all. And I think I did ammonium as well. The salt's not an issue on this one, certainly down to where we've tested. We only tested to 1 metre deep. It would be interesting to test that. I reckon you'd find down the bottom there now that we've actually probably getting a little bit of a salt concentration in that. at about a 150, but yeah, we took it from a core. That's the EC test. The chloride is another salt test, I suppose, really measuring the more toxic part of the total soluble salt, so sodium and chloride. Again, quite low to a metre, but we haven't tested any deeper, and I think we would have perhaps seen a bit more further down. Organic carbon at 0.39, 0.2. Where's Mark? How low is that, Mark? So organic carbon at 0.39, you know, we'd say is pretty low for this soil type, I suppose, and probably representing, you know, an opportunity, as you said, with composts or mulches or whatever else. You're going to see benefits because it's a reasonably low carbon level. You know, you'd be aiming on a sandy loam at least to sort of get it close to, well, probably close to 1, I suppose, on this sort of ground if you could. As to give you an idea. Yeah, the next test across is a phosphorus buffering index, so that's a measure of how much, I suppose, the soil holds the phosphorus. You know, when we get figures certainly around 20, it's quite low on a leaching sand, or if it's really high, it tells you it's holding a lot more phosphorus, I suppose. This one's around the 40, so it's not too bad. Sorry, yeah, around 37, 40. Available P again is the coal well phosphorus test, so I figure around about 45. We tend to sort of target around about 30 to 50 for perennial horticulture, so it's sort of roughly in the ballpark. Potassium available K 310, you know, target, so quite high in terms of potash, so you don't need too much potash. And one of the things, of course, you get out of your grape marker, things like
That's correct.
is a lot of potassium. So you've got plenty of that there. But yeah, it's not, certainly some of the other nutrients, the N and I suppose the P are much more valuable in that sense. A sulphur test of 15 again, which is okay for the level, and we've done some of the traces, and the traces, you know, things like copper have come back pretty high, which is probably because of the sprays over time. I've used copper sprays on this site, and I've built that up to 9. Well, you know, I've got a critical value of 0.3, so you've got some build up of copper. Possibly even zinc and manganese to some extent have been added to this one as well, I would have thought, over time. Traditionally, I suppose, on alkaline soils, yeah, growers may be putting out a sort of zinc manganese spray. I'm not sure whether anyone would know here, just as a either sort of fertigation or a leaf spray.
No, I don't think we're doing anything.
No, and you know, often on alkaline soils, that's sort of almost like done as a insurance spray type of thing, I suppose. Anyway, so you may have built them up historically for those reasons as well, or they may have whacked a bit more out as a solid fertiliser. You would expect, yeah, I mean, it's not particularly calcareous on the top, so those traces will last a reasonable amount of time before they get tied up again, I suppose. On a more calcareous soil, they'll be tied up a bit quicker. We have looked at boron, so boron, something down 110 was actually reasonably low, and we will see other sites where certainly that figure's not quite, actually for horticulture they actually use a figure of more 4, I suppose. Once you get over 4, it's becoming high for boron. I've got the broadacre one there, so sorry about that, over 15. So, you know, boron toxicity certainly does show up through some of the irrigation areas across SA, and I suppose the other test is the sum of cations, which is, we've done this a bit, the cation test, I suppose, for those who know, is cation test, which is your calcium, magnesium, your potassium, I suppose, and that I suppose that it's really a measure of how well those soils are bound to the clay component of the soil. And we've actually done 2 tests on here just to confuse everybody. The top 2 are actually done with a conventional test, and the bottom 3 have actually used the new test that APL's offering, where they actually pre-wash the sample, wash out the soluble salts, so you're getting a more accurate test. So they do vary a little bit, but certainly the figures of sort of, you know, around about that sort of, once we get to sort of 15, we normally say it's a pretty good total cation exchange capacity, and from that we derive an ESP, or an exchangeable sodicity percentage test, which again we want to keep at less than 6, and they all are. And Emily did some dispersion tests here, and none of the soils are dispersing, which is reflected in those low ESP figures, I suppose. So it actually is making sense for once. So those cation tests, just be aware, there's a couple of different tests. The subsoil ones are done using this pre-wash one, so it does measure it low. It actually washes all the soluble salt out and gives you a better test on that. So in terms of the property of this soil, we haven't tested right down the bottom, and you know, we may have picked up some issues once we got down there, I suppose. But we'll leave it at that, I think. All right.